All right, so administrative stuff first, then a slight review of lists, then we'll work on today's exercises. So administrative stuff, 3 things. So section 2, exam, and AI use. Those are our 3 things. So with regards to section 2, I noticed last night I went through and noticed a lot of students in lab 2 in section 2 hadn't demoed their labs. So I met with I spoke with the TA, and there had been a miscommunication against the demoing process. About the demoing process. So for those of you in section 2, yes, you will be demoing your labs to your TA. I apologize for that miscommunication. It does look like the vast majority of you had turned your work in on time, and that's great. You just hadn't done the demoing process, so you can do that with the TA. I apologize that the TA had not quite understood the demoing process where you show them your work. Okay. So the next thing, exams, right. So our first exam, obviously it says, like over here, I don't know, September 2nd. No, don't listen to that. That's just, again, that's a hidden item for when this was originally online. But during COVID, that's when I made this whole shell. Exam 1, right, typically, let's see when that typically is. Normally I'd be giving that around week 6. So the issue is that during week 5, I'm not really seeing a good time for doing review session, especially since I have the 25th already penciled in for an in-class exercise that I'm inviting some professors as guests to. So that wouldn't necessarily make a good lecture for doing the review. So I'll either do a review session on the 30th and give the students in lab 2 an extra, they'll do exam 1 during lab 7, or I'll send out a video. I haven't decided which one, basically, as a review session. It depends on what we need. Typically what I do is that at least a week before the day of the exam, I send out a practice exam. Practice exam I consider to be harder than the actual exam itself, with it also additional problems on it. I then I make sure that I do a session where I go over the answers of the practice exam. Again, depending on the needs of the class, that could be a actual exam. It'd be an in-class section. I've also sent that out as here's a recording from the previous semester. Speaking of recordings from the previous semester, right, I believe that next Tuesday is Rosh Hashanah, so that means I won't be here. So that means that as a result, I will just send out a recorded lecture for you to watch. So if this is your only class today, or you have a class in the morning, right, you can adjust your schedule accordingly. So if you come here, I'll send out an announcement to remind people about it once I send out the lecture. But that does mean that basically if you come here, there won't be anybody here except a few other confused people. Similarly, Yom Kippur is the week afterwards. Yom Kippur takes place 10 days after Rosh Hashanah. That's even a more important holiday. I definitely won't be there for Yom Kippur. This because that day involves a lot of it involves a sundown to sundown fast, and that's just the older I've gotten, the rougher that's gotten. Anyway, long story short, there will be 2 lectures in the upcoming weeks where basically I will be sending out videos instead of the actual lectures. So I apologize for that, as though like I have control over the lunar calendar. So and the way that these things line up, but I don't. And But that being said, if you do have questions, again, even, please feel free to reach out to me. I will respond to you and be able to meet with you at appropriate times, okay? So, all right. And then third, between, geez, this is creaky. Let's get rid of this. All right. Third, the TAs and I have noticed a lot of AI usage, and we've been trying to gently, rather than like throwing you at the academic misconduct wolves and getting you torn apart for this, because I do want to make sure you understand that AI exists as a tool with appropriate use cases. So that's one part of it. Let me start over. There's been a lot of students who have been using AI. We've noticed this. The TAs have noticed it. It's pretty blatant when we see it. At least we assume that's the case, right? We assume that there's cases where we are not able to really detect it as well. Now, rather than just simply throwing students at academic misconduct hearings, which are no fun for anybody, at least at this point, right? We've been trying to gently dissuade students and mention to them, hey, we see this, right? We're pretty sure that you didn't do this yourself. Please do it yourself, right? Or it needs to be rewritten. And if you are relying on that, please see me, and I will be happy to go over any of the previous assignments with you so they get done correctly. And the reason for this is that, and the reason I don't necessarily hammer you with a 0 and immediately is because if you've been relying on AI, I know a lot of students are like, well, why couldn't I just, really? Can I just use AI and get away with it? No, because the exams will utterly slaughter you if you are working with AI. We've seen this in the past semesters, and that was before AI use was very blatant. The exams are set up the way they are so that they will really, it is very apparent from when we do the exams who's been understanding this stuff and who has not been understanding this stuff. So you need to be able to do this work and get it and be able to do it yourself for these exams. Now that being said, I would not necessarily panic if you've been relying on AI so much as get really determined and buckle down and understand that basically you've got to spend the next couple of weeks really working if you've been over relying on AI. Okay, that's what I'm trying to say to you. It's not an insurmountable situation, but if you've been relying on AI to do these things and have been lost in class as a result, you should really reach out to me so that I can help you this weekend. Really reach out so that I can help get you caught up. The book is a great resource. Really, this class, it just requires a time commitment. And using AI for that really robs you of that learning experience, and it can be real. Again, I don't want to make this any harder for you than it has to be, okay? Because nobody likes failing exams, and it's very possible to get a good grade on these exams with basic understanding of the material. Okay. As we get closer and closer to the end of the semester, AI usage will be, I'll give more warnings about AI usage and consequences for that. Right now, we're just at the stage where we're trying to gently warn students, because a lot of you are freshmen, a lot of you are new students, and I try to be gentler about that. Okay. And again, there's cases where I think it's perfectly appropriate to use AI, where you say, hey, there's something wrong with my code. What's wrong with it? Or how do I break down this problem into manageable parts? Those are use cases. These are good use cases. But unfortunately, too often we find there's an over-reliance. All right. So today we are going to be talking about lists. We'll be going over a data set on the on Runestone, and we'll be doing not necessarily data science, but like the first steps of data science. For those of you who don't know, I am the advisor for multiple programs here at Temple. I wear a lot of different hats. So first off, I'm the faculty advisor for two clubs, TU Dev and the TU Gamers Guild, as well as being the advisor for the data science programs, 3 concentrations of data analytics, computer modeling, and bioinformatics, right? As well as the math CS advisor, the physics CS advisor, and the MS computational data science advisor. So I wear a lot of hats. I did not do data science as my major. I just happen to really enjoy mathematics, so I'm able to advise on that a bit more easily than professors who say we're really into biology. That's not to say I don't know a bit of biology. I did take bioinformatics, and that was a very interesting experience. But that's just simply a long way of saying that if you're interested in this stuff, I'd be happy to talk to you. If you have an interest in math classes, I'd be happy to talk to you. If you have questions about that, in general, I'm a person you can talk to about like selections for courses. Now, a lot of you might be also asking, what is data science versus computer science? If computer science is the study of algorithms, data science, the one-sentence definition I would give for it, and this is not something you need to know for the exam, data science, I've read some definitions. The best one-sentence definition is, it is the continuation of statistics through computer science. That is the best one sentence. It's basically continued statistics by using data science. The idea is not just being able to do data collection, data warehousing, data storing, data organizing, or basically doing data analysis, but the entire throughput of that entire job. Now, doing that requires organizing our data. You'll learn about how data gets organized internally in computers in the 3rd class in computer science, which is called data structures. But today we're going to learn about one of these data structures anyway, because we use this data structure in Python as opposed to some other languages use something called an array. Specifically, we need a way to basically for a thing to hold multiple things, right? Right now we've been saying like x is equal to 5, right, to store a single item in X. But oftentimes we need to store multiple things in something. And we've seen that before when we have like a string, right? A string is multiple things. It is multiple letters, right? Literally, this one is multiple letters. I hit enter too early. That's why it said unterminated. I meant to hit the quotation mark, but typing is hard sometimes. So we already have a sequence. This is what a sequence is. A sequence is basically a collection of multiple things. Okay? And we introduced the other type, which is a list, which I'll use L for, as in the previous lecture, right? When we did verbs and stuff like that. It's also been in the videos. Hopefully you've watched those. But if you haven't, this is a list. The bracket symbols, right? Looks kind of like a box. Kind of like the matrices or vectors in mathematics, right? And it shares a lot with that notation. So this is currently an empty list, just doesn't have anything in it. You can add things to a list, pretty straightforward, but we're not going to do that today. We're not going to do that in today's lab. You can add things to a list. You can remove things from a list. But you can, generally speaking, you just kind of deal with a list like this. L is equal to, and this is a list of numbers, 1, 2, 3, 7 to, 6, 9, 1, 7. A list is just, again, a collection of data. Now, just like lists in real life, the order of a list could matter. Sorry, the list has an order, and that order could matter or it could be unimportant. Here, the order is unimportant, right? Because it's just a collection of numbers in this case. But the important thing to realize is that, first off, lists are iterable. For item in L, print item. And it will go through each of these items one at a time, right? 1, 2, 3, 7, 2, 6, 9, 1, 7. That's the order in which this list happened. Okay, so we can iterate through a list in this fairly straightforward manner. Okay, that's one way we can interact with it. Another way we interact with it is by going and asking for specific items or a specific subset of items. This is called the index notation. Now, the index notation, okay, let's see. I believe, like, so at what point do you go over matrices in, like, mathematics here? College algebra, is that where? Like a matrix or something like that? No? But people know what matrices are, right? Yes? Right? A matrix like this, where basically you've got a table, like here's a matrix where basically you've got a row of 2s and a row of 1s, right? Just a date. And we're not going to go over anything complicated like matrix multiplication or anything like that today. That's not what I'm talking about. But there's a notation we use in matrices, right? Which is A is equal, like we might say this is matrix A is equal to this. And if I wanted to get the 0th row in this column over here, right? The first row of the first column, I might say something along the lines of A0, 0 or something like that, okay? Where I use subscript notation. Make sense? Now, just like how if I'm trying to do something like x squared while I'm coding, I can't do a superscript as it's called, right? This is called a superscript. I can't do this in just easy to type text, right? There's ways to do it, but not very easily. Similarly, if I want a subscript, right? And now these are the kind of notations that make students panic, xi, right? Like that, x of I. We can't, doing this is actually a bit of a pain, right? To type out. So a lot of times, as we've seen in when we're writing things out on a computer for superscript, we'll often say x squared, right? So we'll do x caret 2, like that. Okay, that's how we'd typically type it. Similarly, a lot of times you'll see this, but we already use underscore as a variable name, so we can't use that, okay? So as a result, when we want to do subscript notation, we use the bracket notation, and that's what we are kind of going to do. That's kind of where we're getting at here. So simply put, if I want to grab an individual item from a list, I give the list of the name, and then I use this bracket notation again. And I say something like this, L3. And that will give me 7. Why does it give me 7? Because these items have indexes, and these indexes start at 0. In computer science, remember, just like with range, we always start counting with 0. It makes a lot of the other math we have to do easier. So this is index 0, index 1, index 2, index 3. That's why we get this one. L0 gives me 1. Let's go ahead and see how many items are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the last one is 8, right? And that gives me that 7 over here, right? Now, a couple things to consider, right? If I give it an index that doesn't exist, right? And this is covered in the textbook and all the videos, right? If I give it a number that doesn't exist, that's going to give me an error. It's going to give me an index out of range error, right? Makes sense, right? You can't go beyond the list, right? Makes sense. But other programming languages like C actually don't put in those safeguards, and you could get into bad parts of memory, and it would lead to all sorts of mayhem. And similarly, right, just like every other programming language, negative indexes are nonsense and don't give you anything, right? No, Python's actually great. Negative indexes in Python have a special meaning, and I love this feature of the programming language, right? Because often you're trying to think, well, what's the last index in a list? And you notice how I had to count there, right? Well, -1 has a special meaning as an index. It means the last item in the list. And -2 would be the second to last item in the list. So negative indexes, this is more of a less something I'm going to test you on, but more of a, you should know this exists. It's fun. It's useful, So useful, okay? So knowing that these indexes exist. And again, these are very useful for just kind of creating and collating our data and keeping data in one kind of variable, because otherwise you'd need like 50 variables. And then you'd have to make another one if you add another item to your data set. So these lists are very useful. And importantly, a lot of what we're doing here, let's go back to S. S is equal to the word, I'll go with multiple again. You might think of this as list notation, but this is actually sequence notation. You can use this for any sequence, and that includes our strings. So we work with strings the exact same way. So if I say, hey, what is index 2 of this string? It'll give me L, 0, 1, 2. Make sense? S, -1, give me the last letter of multiple. E. Now, also there's this fun thing you can do called slices, but we're not really going to need that. But I will show it just very briefly over here. We're going to need that. You're going to need it on the exam, but not right now. Let's go ahead and do a slice, 0 to 4. This works exactly as the same as a range notation, right? Start at index 0, go up to, but do not include index 4. So this would be mult. Indexes 0, 1, 2, 3. And again, because we're counting at 0, we know it's going to be for long because we take the end, subtract the beginning, and we know how long it is. So, right, S from 5 to up to, but not including index 9, you get pull. In fact, one of the things I love about Python is that with ranges, it's actually safe to do absurd indexes. And that doesn't go out of bounds on those. It just kind of says, we can't end. That's the ending. Okay. So that's our short primer on lists. If you did not watch the videos, if you had, hopefully this is just a nice review, right? Lists and strings, again, they use the same notation and they're wonderful. The vast majority of the exam, I'd say about half of it is probably like points is doing turtles on the exam. And basically, a good amount of it is, there's very little of it is writing code, and a lot of it is, can you follow what the code does for this first exam? Exam 2 is definitely more along the lines of write code, please. Okay. And there's merits to both approaches. Now, here's what we're going to do today. So if you don't mind, please go to Module 4, or go directly to Runestone, and scroll down to Thursday. We're going to do Project 6, and we'll see how far we get today. And I will adjust what gets graded accordingly. So we go down to this Thursday thing, Project 6 from the textbook, and hopefully it will load, okay? And again, you could go directly to Runestone, right? Go directly to Runestone. Oh, am I not logged into Runestone right now? Yeah, I am. Just interesting. Go to your course. Right, I always think it's easier to go through Canvas. Jeez, is the internet just slow today, or is it Runestone that's slow? Sometimes Runestone's slow because a lot of people are using it. So I'll just give people a chance to get there. But you can go there, scroll all the way to the bottom, and choose Chapter 6. Right, so we'll just simply open that as a new tab. Sorry, not Chapter 6, but yeah, scroll all the way. So once you get here, if you're going through Runestone, just scroll all the way to the bottom to Exercise 6, Computing Statistics with Kiva. Iteration, optional, functions, 12 to 12.5, right? All right, so let's talk about Kiva for a second. Kiva is a pretty awesome charity organization. It is a microloan organization. It's a nonprofit. Basically, the idea here is that, and I've done this before, what you do is you donate money to them. And that money and you choose where that money goes, directly to a cause. Let's see. I guess it's just having trouble loading up. But what you do is that basically they take units of 25 and you lend that out to some kind of cause, and it is a loan, so the person is expected to pay it back. And once it gets paid back, well, you don't necessarily get the money back or the interest on it. What you get is you get the money back to loan to another project. So the money stays at Kiva, but you can keep reusing that money again and again to fund more and more projects. So that 25 can become a lot of money very easily. Okay. It's a pretty nifty project, I think. Now, the reason I bring it up is not necessarily because of my personal preferences for charities or anything like that, but but because they have like really nice data sets, very interesting. They nicely provided this slice of their data set of just of 50 items. I believe is it 50? It might be even smaller. It might be like 25. But there's this is from a bigger data set that has 1.4 million rows in it at the time, and I'm sure that it's gotten more. Okay. And we've got this data that we're able to use here for playing with. Now, what is this data? It is essentially from a table. This is from an Excel table, and it's been put into Python essentially for us, as we'll see. Some of these will be like the ID. We're not going to use that, but every loan. What this is data on specific loans. So, for instance, this loan. 212763, and the reason it's like this is because since it's being done for data analysis, we want to protect people's privacy. So here it's just saying, hey, this is the ID of the loan. This is how much was requested for the loan. What country that was from? What country was the origin of that loan? Whether it was funded, all of them were funded in this data set. How long it took to raise, that's interesting. Any guess what the unit is there? Seconds, yeah, seconds. Units in seconds to raise. And then how many people funded that loan in total? In other words, no, not everybody contributed $12.50. That basically 38 people combined contributed $12.50. And this loan was from El Salvador. This one was from Bolivia. This one for $100 in the Philippines was funded by a single person, right? So we've got we've got this data set of countries and stuff. And wow, it's not. Is this having issues with loading? Is that having issues with? Is anybody else having issues with this? Because those are supposed to be text boxes here. Those are supposed to be coding boxes. I am loath to abort a lesson like this, but if I need to, I will, and just simply talk about doing this stuff with my own personal examples. I am a flex. Okay, there we go. There we go. So it just took a bit. Now, go ahead and just hit save and run so it registers that you interact with this. But all these all these columns essentially have been laid on their side and turned into rows over here, right? Loan amount, country name, time to raise, num lenders total, right? So all the data is here, and even though it doesn't appear here, it's been kind of silently loaded in the background. Here, I'll show you. Num lenders total, I'm just going to copy that for a second. Num lenders total 0, and I'm just going to ask to print that out in this first one. And hit run, and it's there. All right, and we see that we're using unit tests, that there's unit tests running on this to detect whether or not we got the correct answer. Right now we don't care, but right now we just wanted to show that even though these variables aren't showing up, they're just keeping the code clean, but these rows are here. Loan amount, country name, time to raise, num lender's total. Okay, now what we do notice is that 1250, Azerbaijan, 193075 and 38. 1250, Azerbaijan, 19375, 38, right? The index 0 corresponds to the first row. Index 1 corresponds to the second row, and so on and so forth. So all these are basically, all these line up. Not necessarily like visually, but like the indexes line up. So if it's in the first slot, they all go together. If it's in the second slot, they all go together. If it's the third slot, they're all paired together. So we're going to start working on some basic analysis questions. Compute the total money loaned and store it in the variable loan total. So we're going to need to use the loan amount, right? Because that holds the amount of data. Okay? So you're going to need to use loan amount. That's what we're going to need to use. And it says we want to store it in the variable loan total. So what we're doing here is your classic running sum. Loan total is equal to 0, and then we'll want to do magic and then print out loan total. Okay? And what we should do is we should take every item in the loan amount and add it to loan total. Basically, you want a for loop to iterate over this. So take a few minutes to do it to yourself. Remember, basically the format is for item in thing, for item in your collection. The collection name is loan amount. So just make sure you can get there. This should be, if you've been keeping up with the reading, this should be fairly straightforward. Although I know a lot of times when you're being asked to do something on the spot, it can be like, oh no, what am I doing? Oh, please tell me that I started the okay, I did start the recording. And fortunately, as you see here, these messages at the bottom, these unit tests will tell you, have you done it right? All right. So, let's go ahead and go over this, right? So the goal is to figure out the total amount of money that has been loaned. Loan amount, that list has all the amount of money that has been added, right? Sorry, all the amount of money that's been loaned out. So the item, what we're trying to do is we are trying to basically sum up this column, right? We're trying to sum this up. Now, or we're going to, and it's stored in this list over here, loan amount. So what we need to do is we need to iterate over this list, basically go number by number and add that up into an accumulator, as again we call it. It's a running sum. Now we start at 0 because anything we add to 0 will be itself. 0 is the identity. We add our first number to 0. We'll have our first number. Then we can add our second number to that. Then the third and the fourth. So we can iterate over this in a very straightforward way. So we can go for, and I'll use a different variable here. I'll say for num in loan amount, right? Colon. And it doesn't really matter what variable you use here as long as you use the same variable in the next line, right? So, and then what we can do is we can say, loan total is equal to loan underscore total, the current value that we have stored, plus num. So what this does, this for loop goes over for every single number in loan amount, do the following. Take the current amount that we have stored, add the current value I'm looking at it, and store it in loan total. Then go to the next number, and the next number, and the next number. Number changes value. It's a variable, right? It varies in value. And then we go ahead and run this. Now, also, some of you who have been reading ahead or have taken something like this class before may be wondering, why don't I just simply be lazy and just simply do this, print, and do the following instead? Like, do this instead of this. Loan total is equal to sum loan amount, which is a function that does exactly what this for loop does. Now, first off, that would fail this particular test because they don't want you to use the sum function. But as far as I'm concerned, in any assignment, any exam, if it exists in Python, you can use it, right? So there is a function that literally does this, the sum function, and that's very useful. But that's also why you won't see me when I'm using a running sum, you won't see me using the variable name sum, because it could get confusing. So, so there. So now, what we need to do is we need to compute the average amount of money. So first off, I'm going to share this, okay? Because this is useful for the next part, which is compute the average amount of money loaned out and stored in the variable loan average. Now, as a reminder, for those of you who want to compute we want to know how to compute the average or the mean, right, as it's sometimes called, right? The average is just simply taking the sum of all the things that you're looking at and dividing it by the number of things you just added together, okay? Oh no, do I have to count how many items I've added? That you could, that would be a pain, but you could, right? You could have a variable what you could do is you could have like a count variable that you could increase by 1 each time you added something. But honestly, that's a pain. And in other programming languages, like older programming languages like C, that was like a necessary thing you'd have to do. It was a pain. Nobody likes doing that. Python has one awesome function that is universal that says if I need to know how big something is, I'm going to use this function. And that's called len. So just like print, use it just like print, only it gives you a number. It doesn't print something out. What len does is says, so here we have our list over here, L, right? This one was 9 items long. If I ask for what its length is, it will tell me 9. If I ask for the len of hello, it'll tell me 5, right? It tells you how big something is. Len is very useful. So that can tell you, so that will tell you how many things we've added up, right? If you add, so you can use this to compute the average, right? The average is just simply the number of things we added up. Sorry, the average is the sum of all the things we add up divided by the sum of all the things we added up divided by the number of things we added up. So I've copied over the code from the previous one to get you started. Use that to compute lone average. God, this is squeaky. right, so we want to compute the lone average. The lone average occurs after, well, we need to calculate two things, which is the sum of all the things, which we have, divided by the number of things that we added together. So the sum of all the loans divided by the number of loans there were. So we've already done the first. So to do the second, we will do, what we need to do for that is say loan underscore average is equal to loan underscore total divided by length of loan amount. Why these two things, right? Loan total is our running sum, and length loan amount is the collection of all the things we added up. That tells you how big it is. And sorry, this tells you how big it is. So if we run it, that gets us our value. Okay. Now, let's go ahead and, so this one's a bit trickier. So, given that and the amount of time we have, let's see. I think I will go over this one maybe a bit directly. Let's see. Store the amount of the minimum loan in min loan and the maximum loan in max loan. So it wants us to find the biggest and smallest loans. That's the first part. Then store the name of the country that received the largest loan in max country and the smallest loan in min country. And I think this is a good one because this is going to introduce a bunch of very useful functions for us that are built in to lists and stuff like that. Okay, so store the amount, and it says hint, max and min are functions built that you can use to find the maximum or minimum value in a sequence, right? And we can just kind of test this over in our test sequences over here, right? For a refresher, here's L and here's S, right? If I ask max of L, it's going to tell me 9. That's the biggest value. Make sense? Very intuitive. Min of L, it's going to give me 1. Okay? Any guesses of what the max value of S is going to be? The max if I throw max into this, any guesses? It's an unusual case. So assuming it's not error, what would be the least surprising thing? What? 9? For S? For S. For S being multiple, the word multiple. Yes, it would be the letter that's closest to the end of the alphabet. So in that case, U. It's asking, so it's asking, max asks what's the biggest thing is in here. And in terms of Python, it's asking that the size of the quote-unquote size of a letter is the closer it is to the end, right? We put things in order from least to greatest. So the greatest letter comes at the end, right? Similarly, if I ask for the min. This is a very super niche use case, but I just wanted to kind of show it. Again, that sequences, that strings, and lists work basically exactly the same. They just kind of are subtly different. Okay? So we can ask for, we can work with loan amount again, and we can ask min loan, and just simply say min loan is equal to the min of the loan amount. Assuming I can remember to spell loan amount. And we run it, and we'll see that our first value is pass. And then it doesn't give me the second value. I don't pass the second because obviously I haven't written that bit yet, which is, right, if it's fair. Even if you walked into this class like right now, this next part is pretty easy to figure out, right? Which is that, if I want the min, and if I've got the min and I want the max, I just simply change all instances of min to max, right? it is nice when those things line up. Now, the issue is, how do I find out what these countries are? Right? Without like cross-referencing, like physically me going and looking at the list. Okay, first thing first, let's go ahead and just refresh our memory on what the variables are though, right? The variable names are, if I want the names of countries, are country name, okay? So how do I know which of these numbers goes with this one? As I mentioned, right, if it's in the first slot, everything that's in the same row is in the first slot, then the second slot together, the third slot together, fourth slot, everything's together. So they're all at the same index. So the question becomes, what index is this at? Right, now, if you're coming from another language, right, already programming experience, you might already be thinking, like, I need to iterate through this and say, if this is equal, but we aren't at if statements yet. So how do we do that? Well, Python has a built-in function to help us, and it's called the index function. Let's go ahead and take a look at how to use it, right? S.index of, let's go ahead and say P. It says 5. 0, 1, 2, 3, 4, 5. It tells us what index that occurs at. Okay? Let's go ahead and do L.index of 9. That's 6. Right? Index 6. This one's a good one to ask. L.index of 2. There's 2 2s in here, right? In this list. There's 2 2s, and it returned index 1. So, least surprising thing is that it's lazy, and it returns the first index it finds. So, that's how we can use this. We can ask, what index is min_lone at? So, min country is equal to country name, right? That's the one with all of the, that's the list with all the names in it, dot index of, well, country name, that's actually not how we do it. That is, sorry, I'm just thinking to myself, because this actually would require basically a function call inside this, which looks very icky, right? At least at first, to a lot of people. So let's go ahead and break this up a bit into 2 steps. Let's go ahead and create a min index to figure out what index this is at. Right? Does that make sense? We're going to do this. Break it up into steps. So the index where we can find the minimum loan is loan underscore amount dot index of the min loan. So we basically got it from loan amount, and now we're going to ask the loan amount for this amount. And that's fine. And then we go ahead and say we are going to take this and ask min country for that amount. So we're going to just simply put these things together like that. And we find out that the country with the minimum loan is the Philippines. Right? So we got the min loan. We asked what index that's at. Let's go ahead and debug a bit by printing. Print min underscore index. That was at index 5. So then we got the country name that was at index 5, which is the Philippines. Make sense? So we had Python do all the work for us, essentially. We asked where it was. We asked what the minimum was. We asked where that minimum amount was. And then we went to the corresponding place in a different list to get that name. Make sense? Because we knew that the country with that amount would be at the same place. And then again, it's the same exact thing for the max, where we just simply are going to change all instances of min to max to get the max, to get the biggest loan. Max loan, max index, max country, max index. And that is the country of Georgia. Right? As opposed to the state of Georgia. So this one, again, it makes use of some powerful functions in it. And I think a lot, the hardest thing is like, for some students to understand is why are some of these things wrapped like this, where some function calls like this, and some function calls like this. These functions like this can basically are built into Python, and they can be used on pretty much anything, whereas this index function is specific to lists. It's something specifically lists and sequences can do. Max can be used in a lot of different other ways. Like I can literally use it like this, max of, and I can just throw numbers into it, and it will tell me which is the biggest of the numbers I threw into it. So there's a lot of different ways to use it. All right. So now that we've had a palette cleanser, I think this is a good one to do. Compute the average number of lenders per loan and store it in the variable average lenders. Okay? Right? So here's our average num lenders total is our row. This tells us how many people made loans to people, how many lenders there were. And I want to find out the average number of lenders there were. So this should follow the exact same format as the previous problem. So this is a good chance to retry that. Just different data set. Let me just see what the other... All right, so with it being 3:05, I think I'm going to speed through the next couple. So, all right, this one, again, we were trying to compute the average number of lenders. So we're going to get the total number of lenders. It's equal to 0. And what we're going to do is we're going to ask for n in num, I think the variable was what? Num lenders total. Let's go ahead. I have very poor variable name. Num lenders total. Yep, num lenders total. Total lenders is equal to total underscore lenders plus n. Then we do very straightforward what we did last time, which is it was asking for average lenders. Average lenders is equal to total lenders divided by the number of loans there were, which is len total lenders, len of num lenders total. I would have just simply called that lender or num lenders. And that gives us, again, very similar to the previous problem. Now, this one's not. Compute the total number of loans made to the Philippines and store it in the variable Philippines count. Now, kind of actually gives us the answer to the question right there, and I think this is actually the shortest program in this exercise. Because how do we figure out the number of loans that were made to the Philippines? Well, how would you do it if you were doing it by hand? You'd go to this column or this list, and you'd scroll down and you'd count the number of times Philippines appears. And that's what we would do, with our code. Now, that being said, again, what we'd have to do is we'd have to write a for loop with an if statement, but we don't need no if statements yet. So instead, we're going to use a function built in to our code, which is very simple. Philippines. And I think actually the hardest part about this will be spelling the Philippines. It's 1 L, 2 P's. Count is equal to country name. Is it country name or country names? Country name, singular. Ugh. Country name dot count, which does exactly what you'd imagine it to do. Philippines. And it will store it in that variable, which is, it counts it for us and gives us 7. Now, if I had misspelled it, by the way, if you get 0, it's probably because you misspelled it. Obviously, if there's not a country named the Philippines, right? Just like if I looked for a country named Taco, it wouldn't appear, right? Okay. Now it's saying for each country name, our last problem is for each country name, print a line that shows the name of the country and then the number of loans that were made in that country. Like this, Guatemala 1. So this one is not too bad because we kind of have the answer on how to do that in this one, which is we ask for the count of it from country name. The key here is that we basically don't enter the country names manually. We are lazy. We have an iterable right here. We have the list of all country names. So what we're going to do is we are going to say for name in unique countries, we are going to print out that name, and that's going to be the first part of that, right? We could just simply see that that runs and then print out all the names here. We're going to need to print out one more thing, which is that count. Okay? So we're going to say country underscore name, just like we did above, dot count, right? That's what we did in the previous problem. Country name dot count. Only instead of putting in a specific name, we're going to put in the variable. Right? Count of this name. So for each name in unique countries, we are going to print out that name that we're currently looking at, and then what the result is after we feed that name into countryname.count. And that gives us the desired result. Questions about this one? This last one for today. Any questions about this one? Right? We could split this up, right, into two statements if this bothers you, doing it like this, having a function call inside a function. In fact, that's no problem. But we might create a variable called amount over here and say amount is equal to countryname.count name, and that tells you the amount of loans that were made. And then print that variable, still the same thing. We just split it up. Multiple ways to do these things. So Python has a whole lot of very useful tools for going through lists, for manipulating lists, to make it just nice and straightforward. All right? All right. With that, it looks like 3:12, and that is pretty much all I have for the day. I think this is a good place to stop. If you have questions, please come up and ask me. I'd be happy to talk to you. I hope you have a good weekend. Okay?